Good. So what's next? You found the offending query. Let's improve it. So how do we improve it? I'm going to talk a little bit quickly about index selection rules. I've done this talk or this section of the talk in the past. I'll run through it quickly. But again, if you have questions, please either go ahead and ask or come see me afterwards. But I think the most important thing that you have to know is that, one, the rules that I'm going to show you, they're implied in order. And they're not selection rules, they're elimination rules, okay? So what happens is you start with all the indexes, and then based on the where clause, we start eliminating indexes based on the rules I'm about to show you. So think elimination, don't think selection of the rules. And then the second thing, I mentioned this already 11 times in the past half hour, field matches must be contiguous from the first field in the index. You cannot do field 1 and field 3 of your index. It doesn't work. You have to do field 1, then field 2, then field 3. And I often get this question, does the order in the where clause matter? No. I mean, the fields have to be there, but you don't have to put them in the correct order in the where clause. All right? So here's the selection rules. And I have a nice little board that we use. Was anybody in our indexing workshop 5 years ago? One person was here, right? So you saw those grids that we did 5 years ago. So it's a little bit the same thing. The first thing that the compiler does is it pre-selects only indexes where the leading component of the index is in the where clause. It just says, hey, if your where clause is on name, and the first, and I have an index on country, I'm not even going to consider country. I'm going to eliminate country right away because I don't have country in my where clause. So let's pre-select all of the indexes only where the leading component is in the where clause, right? Second rule, if I see contains, it's a word index. Ignore all the rest. It's going to be a word index that I'm going to use, all right? Third rule, do I have any unique indexes that have, all components involved in the equality match, all right? And so if I don't, I eliminate those other indexes. Why do I want to prefer a unique index with all components involved in equality matches? Because it'll return me one record, right? If I have equality on a unique index, I know by definition it's going to return one record. It's essentially a find that you're doing. So I'm going to prefer that. And then after that, most active equality matches. So I'm going to say, okay, for each one of those indexes that have not yet been eliminated, I have 2 equality matches, 2 equality matches, 1 equality match, 3 equality match. I'm going to eliminate all the ones except the ones that have the most equality matches. And then I'll go to the next rule, right? Most active range matches, and then most active sort matches. And eventually I expect to be left with only one index. Now, if I've gotten this far and there's still more than one index available, I'm going to pick the primary index if it's still available. And then this is the one that always freaks people out. If I get here and I still have more than one index, I'm going to pick the first one by name. And the reason this should freak you out is it means because if you add an index that sorts higher alphabetically 6 years from now, you just broke some code. And you don't even know that you broke the code because that index was being selected alphabetically. So watch out for that.
I found the last issue was one of the reasons why people end up using use index, because the system ended up going through that big whole sort, which I activated them, which I'm very happy that you shared with me. And then it gets it there, and all of a sudden it doesn't find the one you want to use.
So you force it.
Yeah. At the port, so you force it.
So I have always said, if you need to use index, use index, right? But I always say if you need to use index, there should be a paragraph above that query that explains that you're not an idiot and you're not lazy, you actually did the analysis, right? And you decided for whatever reason that you were going to force the usage of this index for this reason. Now, the next person might still disagree with you, but at least there's an explanation. And if you didn't put the explanation, then the hotshot developer who's going to come after you is just going to erase the use index because he heard some guy come up on stage and say you shouldn't use index. And he's like, oh, I'm going to remove that. That's some old guy put that use index there, you know? And then just screw up the entire program. So.
And they won't know why.
Of course not. That is the. Who has children here? Everyone has children. This is the beauty of children, you know? They're so confident in everything they tell you, and until you show them they're wrong, and then they're like, that's impossible. I'm wrong. All right. So some examples. All right, for each order, where order num is 1, 2, 3, 4, 5, or where order num equals 1, 2, 3, 4, 5, and cust num equals 5. I think I'm running low on time, so I'm going to go fast through these. You can see that we have cust order, order date, and so on and so forth. So what we did here is we created these elimination tables as part of our workshop we did, 5 years ago, 6 years ago here. And again, so we start eliminating, so we do the pre-filtering, right? So we eliminate these ones over here, the grayed out ones, that where the leading component isn't sales reps and isn't order status, and we're left with these 4, and we start eliminating. Is there contains? No, okay, we didn't eliminate. Are there unique indexes? No, we didn't eliminate. Oh, and then we end up here using the 2 indexes because I have an index on sales rep and I have an index on order status, and the selection rule for more than one index says all equality matches on all the components of the index allows you to use more than one index, which I think is the next slide. Yeah, all components involved in equality matches. Now, OR is another tricky one. If you see an or if you include an or in your where clause, understand that the compiler will actually compile 2 separate queries and will evaluate the 2 sides of the OR clause separately. So you have OR, take the stuff on this side of the OR, you run that through the rules. You take the stuff on this side of the OR, you run that through the rules. That will select 2 search paths to the data, and at the end, the result sets will be combined in some random order that you don't know. And then that data will be returned to you. All right? Yes.
If you specify use index on a query, you're preventing the compiler from using multiple indexes or multiple brackets on one index.
If you use index, you're preventing the compiler from using multiple index or from using multiple brackets on the same index. So good. Again, use index, use sparingly. It should be use sparingly. Index should be the keyword. All right. Expressions break bracketing. Don't forget that, right? People learn this the hard way, one way or another. But the minute you wrap something around a field that needs to modify the field, that'll break the bracketing. So essentially, the compiler will just ignore that field, right? Month of order date. There is no month of order date field. And certainly, it's not the database server, if you will, for lack of a better term, that's going to evaluate that. It's going to be your client AVM. So essentially, it's an if, right? You're saying for each order, no lock, : if month of order date, blah, 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 right? So any kind of bracket will break expressions, but begins is not considered an expression because it's really just a range match, right? But matches is like month of, right? Matches needs to look somewhere in the field. That'll break bracketing, but begins won't break bracketing for you. All right, and temp table rules are a little bit different in that last rule where I said they were ordered alphabetically. If you're doing the same thing on a temp table, there is no alphabetical ordering of the indexes on the table, so then it selects the first one by order of creation of the temp table, right? It'll just go, which is the first one that's still there? Oh, this one, thank you very much. But that's the subtle difference with temp tables. All right, I talked about this. Each side of the OR is done separately and then combined. And here's an example. So you can see here it's chopped off. So I say where order status equals ordered or sales rep equals BB. So you can see here, I'm reading the order status table 334,000 times and the sales rep table 81,000 times.
Index.
Index, times. And then the two are combined at the end to give you your result set. All right, so that's showing me here very clearly that I'm using both indexes to satisfy this query. Good. And your log manager will show you the same thing, right? So once again, I can see here, I'm using my table order, and then I've got my two indexes that I'm selecting. So same information is available in the log manager if you use that. I think I'm wrapping up. Table scans. If you expect to read more than a third or so of the table, just read the whole thing, right? Why bother? I mean, unless you absolutely need to process the records in some indexed order, right? If you're going to read a third, just read the whole thing, right? Because you're going to add at least another third equivalent in index reads, so you're already at least to 2/3 to 3/4 the number of reads. Might as well just table scan for each table scan and read the whole thing. One caveat, the table has to be in a type 2 storage area for this to work. Otherwise, it'll still use the primary index when you do it. So just more efficient, just run through all the records if you're going to run through, a third or half of them anyways.
11.0 and later.
11.0 and later when the table scan option was added. Is anybody still running 10.2? 9? Are you just too embarrassed to lift your hand? We still have customers running 9.1e still. So. All right. Okay. Client server queries are going to be slower, no question. Why? The data's got to be transported across the network back and forth. Don't forget that. And those records are transported in these messages, and the message size is set by the -mm, right? So without going into any kind of huge details about these settings, I still wanted to mention them to you guys before I closed up shop. Use no lock. If you don't use no lock, it's one record per message for shared lock and exclusive lock, right? So you just, multiplied your network chatter by 10 or 20 easily, right? Use field lists. We're lazy because most of you programmed from the character days and you just expect all the fields to be there all the time. And you were right when you were in shared memory because your shared memory user just went into memory and said, I want, this field, right? But in client server, you've got to take that entire record, ship it across the network. But if you only need one field, we'll only ship one field across the network. Why do we want to do that? Because we can cram X number of records into a network buffer, a message buffer that we ship across the network. And if you send the whole record and it's 100 bytes, then maybe I can only send 40 records or 10 records. But if I'm only sending the name, maybe I can send 100 records. So I'm reducing the chatter back and forth. And the 4GL is a very chatty network protocol. So anything you can do it. So increase your message buffer size. I would say at least 8K or 16K. All the benchmarks we've done, like the performance kind of goes like this to 8K, like this to 16K, and then kind of flattens out as you go to 32K. So I would say just set it to 16K. Some people will say just set it to the maximum, but whatever. I don't think there's a big difference between 16K and 32K for the size of the message buffer size. And use the prefetch parameters that are available to you since 11 something, 6-ish, 4-ish. I think they came out in 4, but they were not working properly until 11.6-ish or so.
Prefetch?
Yeah.
That's 10 to be 06 and 11.
Oh, 10 to be 06 then.
And 11.1.
And 11.1. All right, so again, it should be all available to you to use the prefetch parameters. The most important things with the prefetch, do I have them here? I don't. With the prefetch parameters, again, essentially what you're saying is cram as many records as possible into the message buffer. All right. Now for the parameter, if you're running, sorry, I don't remember what version when they switched it. In older versions of Progress, the client and the server had to have the same parameter, otherwise they wouldn't connect. But as of 11 something, I don't know, 6-ish or so,
It's 11.6.
11.6-ish or so, the client will always take the server's value. So you set on the server, and the client will take that value. And again, set it to 16K and just forget about it from there. All right, cram as much as you can, and you can benchmark this. You see the curves, like it's amazing when you set the prefetch parameters and the and you quintuple the volume of data you can send across the network, right, with the same query. Really, really important. I think I'm almost done. I've only got a few more minutes. None of this applies to SQL. Did anybody come to my SQL talk the other day? No? See? Then you missed all the SQL stuff. None of this applies to SQL. You can download the SQL talk I did a couple of days ago where I talk about the SQL optimizers and how the SQL queries work. But nothing of what I said applies to SQL at all. All right?